15 here? Look over these quizzes and make sure you understand any mistakes you made. I bet once a lot of you got home, you realized maybe some of what you've done. Are there any of those you would like me to work on the board that you really couldn't understand why it was what it was? You know, on the limit ones, number 2, 2a, you could just plug the number right in for x, couldn't you? In 2b, you had to factor and cancel, then let x approach the value. And you would have got what I put on here. On number 3, the limits on there, notice that in 3a, if you divide everything by x, you have 1 over x over 1 minus 5 over x. Well, that gives you, if x approaches infinity, that gives you 0 over 1, doesn't it? So it goes to 0. Okay. 3b, if you did that dividing everything by x, you had 6 over 3 left, which was 2. All right. 3c was probably the trickiest one. Just think about it. 3c was something like the limit as x approaches negative infinity of x squared plus 3. Well, there's no fraction there, right? So if x goes to negative infinity and you square negative infinity, where's that going? That's going to huge numbers, larger and larger and larger. Right? The smaller it gets, if you square it, it gets huge positively, doesn't it? So in 3D, if you divided everything by x squared, you got 5 over negative 2. 5 over 0 minus negative 2, minus 2, and that would give you negative 5 halves. Okay. The other mainly missed problem was number 5. What I really wanted you to do, remember, if you're given the supply and demand functions to find the point of equilibrium, you just set them equal to each other. Where do they meet, right? So I wanted you to say, where does the supply meet the demand? If you make one side 0, that's a nice quadratic. If I add 2x, that would be 5x. And if I subtract 14, that's an easy one to factor, isn't it? I think you get something like plus 7 minus 2. Would you agree with that? If you set them to 0, x is negative 7 or x is 2. Well, I couldn't have a supply of negative 7. The supply x was in millions of chips. I couldn't have negative 7 million chips. So my answer is 2 for the equilibrium quantity. So that was the answer to A, was 2 million chips. And to find the equilibrium price, put that 2 back into either of those functions. And if I put the 2 there, that gives me S of 2 equals D of 2 equals $10 per chip. And if you had the other form, it was 2.54 million. Yeah, this was 2.54 and that was 3.92. Okay. I think, yeah, if you had the other quiz, you probably had to use the quadratic formula to find the 2.54 or graph it and find the intercepts. But this was one of the forms, and that was fine. And I think at the top, if you made a mistake on those composition questions, you could find your mistake, I bet. Just remember how we did those. But yeah, I was mostly disappointed in some of the limits. Some of you got confused on the limits, but I think once you look at them again, it'll be okay, I hope. But if not, stick around after class and I'll go over any of these you need me to with you. So, all right. Did you have any homework questions? That's next on the...
On some of the homework questions, they like had isotopes. I don't know how we used to say like the number of equilibrium is negative number or negative infinity.
Mm-hmm.
Well, like in the answers in the back, it says it does not exist.
Yes. Remember I was saying that sometimes those that I said, I would define it being infinity, that the book would say does not exist for some of them, and I disagree with them on that. But that's that theorem I gave you. And you'll see that on the quiz I hand out today. If I give you something like this, the limit as x approaches 3 from the right-hand side, what if I said 3 over x minus 3? How would you use that theorem I gave you to evaluate that? Remember that theorem said, if you plug in a number a little to the right of 3, you look at the sign of it, right? Since that would be 3 over 0 undefined, wouldn't it? But if I put in a number like 3.001, is this fraction positive or negative? It would be positive, wouldn't it? A number a little larger than 3 would make that positive, so that would go to positive infinity if you approach from the right. And look at how I could sort of show you that. If you didn't buy that, you could graph it. You could say 3 divided by x minus 3. Well, look at that. Minus 3. Here we go. If I just graph that on the standard window, okay, if you get closer and closer and closer to 3 from the right, where is it going? To infinity, right? And that little theorem helps me do that without having to graph it. If I had a little minus here, if I was approaching from the left, I would put in a number like 2.99, and I would say, what's the sign of that fraction? Well, it would be negative, wouldn't it? That means it would go to negative infinity. And if you look at my graph, if you approach this 3 from the left-hand side, where is it going? Negative infinity, isn't it? If you approach from the left. So that's that theorem, and you'll see that on the quiz that I'll give you as a take-home. Okay? But yeah, there is all. I don't know why they wanted to do that, because there is that theorem I gave you that is clear as a bell that defines that as the limit being infinity. But a few of them they said does not exist, and I didn't want that to confuse you. So, okay. How about any others? Any specific ones we should look at? 31, and what page was it? Okay. Let's see. They say, what's the limit as x approaches negative 2 from the right of 2x plus square root of 2 plus x. if we look at that, if I'm approaching -2 from the right-hand side, that means if I'm coming from the right, that's a little larger than -2, like -1.99. So this would approach 0, wouldn't it, if you approach from the right? But if you put it here, that would approach -4, wouldn't it? So it'd be like -4 plus 0, and it would go to -4. The problem with that one is if they would have said approaching from the left, I can't approach under that radical from the left because I would be putting something in there like -2.001, and that would be imaginary, wouldn't it? So that would mean the left-hand limit would not exist. And if there was no sign here at all, that limit as x approaches -2 would not exist because I can't say that the right and the left hand approach that same value -4. Does that make sense? Okay. But yet from the right, this will go to 0 as you get close to -2 from the right, and this will go to -4. Any others? Did most of the ones on continuity make sense to you with those 3 conditions of continuity we went over last time? Okay.
Well, like, I don't know, some of them when you graphed them, they kind of got confusing as to whether or where they, and I was wondering if you go over like 50, like 51 or 57,
Okay.
whichever one you think
All right.
maybe.
Okay. Miss Tucker would like to say a few words about the student success center.
Tom got away from me.
Oh, thank you.
Go ahead and give it back to you. How are y'all doing?
I'll bring up the website.
All right, thank you so much. Sorry, Tom got away from me. I feel bad interrupting your class once you guys have already gotten started. I wanted just to kind of let you know of some help that is available to you through the Academic Success Center. If you go through the current students section, you'll find all of our information is kind of located here on the side. There's several services that we offer to you, from peer tutoring services to online writing consultations, workshops, professional tutoring, and all of those things. The peer tutors are in the lab from 8 o'clock until 5:30 Monday through Thursday, and then from 8 o'clock until 4:30 on Fridays. We have a number of wonderful tutors that are available to help you with math, with science, and also with English. And so you can look at the schedules that are available and see who's here to help you. We also have some professional tutors that are available to you as well. Ms. Elizabeth Gonzalez is the coordinator of the ASC, and she can help you with math, she can help you with Spanish. Ms. Ruth Harvey is here Tuesdays and Wednesdays, and she can help you with English, writing skills, reading skills, and study skills. And then I'm here, and I'm the tutor lab manager, but I can also help you with English and history. The study skills part of it, all of us can help you if you need help with note-taking or test-taking or those sorts of things. So please come and see us if there's any of that kind of interests you. We also have workshops available. We're kind of at the end of January, 4th week, if you can believe that. And so we're kind of out of workshops for this month, but starting in February, there'll be some more workshops available, whether it's the note-taking skills or resume writing sometimes, those kinds of things. So you can just kind of check the website and see what's available to you there. We do have an online writing consultation that's available to you, that if you have a paper that you would like to submit for a tutor to look over without actually having to come to the lab, you can submit that to them, and the tutors will look over your paper, send that information back to you. They never change anything in your paper. They'll highlight things that you might want to look at again, and then it's up to you to decide whether or not you want to take their suggestions. We do ask that you give them 24 hours to look over your paper, not including Saturdays and Sundays, and they'll get that back to you. And then one of the biggest things that can help you is the smart thinking. how many of you have used Smart Thinking? Amazing tool that you have at your disposal. Smart Thinking is that online tutoring program that you can log in and have a professional tutor at your fingertips. You go through your D2L account and you can hook up with a live professional tutor. We only have one math tutor that can really help out with calculus, and so this is going to be a service that's going to really benefit you, because I know that's one of the subjects that are listed. So there's drop-in tutoring that's available. There's also scheduled tutor that's available. So if you look on the webpage and the calculus tutor is not available at the time that you click on, you can make a reservation 48 hours in advance, and you can meet up with that tutor. They are all over the country, and so you can make some of these appointments 10, 11, 12 o'clock at night if that kind of better fits into your schedule. You get 240 minutes of this tutoring that you can use at your discretion. So please take advantage of that free tutoring service that is available to you. Now, I did say that we had the one math tutor that could really help you in calculus. If you come over, we have others who will do their best to help you. I don't want to embarrass Justin, but he's one of the best ones that we have. And he can kind of help you through, I know, embarrass you, I'm sorry. Can help you with different things that you have going on. But I promise that if you come to the tutoring lab, we will not let you leave without a help in a direction somewhere. Whether it's getting you online to find help, whether it's giving you paperwork to give help, or whether it's matching you up with someone who can help you. Our sole purpose in existence is to help you succeed in your studies. So please take advantage of what we offer over in the tutoring center. We really want to help you with any kind of issue that you may be having. And please don't wait. It's already week 4. Please don't wait till you feel like you're drowning before you reach out and ask for help, because then that just makes all the frustration and the struggling even more so. So come see us so we can kind of get a handle on it before things get out of hand, to help you be a success and learn while you're here to learn. Any questions? All right. Thank you.
You said maybe, did you say 51 on Richmond Center?
Or like 53, for some reason. I was wanting to say that it would go from negative infinity to half, and then...
Think about a good way to look at this question. Let's see. If this is the piecewise function, you could graph it, but you really don't have to. Let's just look at it. If you have this, and these are the pieces, oops, less than or equal to 1, less than or equal to 1 and greater than. Okay? They're saying find the values for which each function is continuous. Okay? Well, let's first think, where could it be discontinuous? If these were just alone, they would be continuous everywhere, wouldn't they? But what I'm afraid of is where it splits at 1, where those two pieces split. I would want to test that. Okay? So I'm going to say, let's look at 1. At x equal 1, let's do our 3 conditions. First condition, what is f of 1? I would put it in this piece, and that would be 1, wouldn't it? What is the limit as x approaches 1 of f of x? Well, if I get close to 1 from the left side, from less than or equal to 1, it goes to 1. If I get close to 1 from above, 2 minus 1 is 1, so that limits 1 to 1. So since this is equal to that, all 3 conditions are met, aren't they? So I'm not scared about any other values. That means it's continuous everywhere. That's what you could say. Continuous everywhere. Or you could say from negative infinity to infinity. There are no bad values for x. It's continuous. It's a solid curve throughout. Since we tested that one trouble spot that we were worried about, where the function split, 1 was fine, so everything else should be fine. Okay? And you didn't even have to graph that. Okay?
Well, I guess what threw me is all the other previous ones had it, you know,
The
as
discontinuous
union and,
or something.
and so
Yeah.
and it was like,
And the way they worded that, find the
Yeah.
values for which it's continuous.
right.
And if the 1 wouldn't have worked, we might have said all real numbers except 1, which would have been what, like negative infinity to 1, union 1 to infinity? And that's, of course, the way they would say it to make things a little more mathematical. Or you could have said all real numbers, x not equal to 1. But it was good at 1, so that's nice. Any other concerns before we finish our notes? Okay. Let's go back then to what we left off with. We were beginning to 6. And I said on page 147, we're just going to do a very little before this unit test that I'm hoping to have Monday. Okay? So, if we go back to those notes we were looking at, we'd said that if you want to find the average velocity or average rate of change, that's basically the slope between 2 points, isn't it? That's the slope. Change in distance over change in time, basically the slope of those 2 points. Okay? Just to give you an example to go with this before I define instantaneous velocity, why don't we start with the first part of number 30. This is a good one to look at. This is on 147. Says, a ball is thrown straight up with an initial velocity of 128 feet per second, so that its height in feet is given by this distance function, s of t equals 128t minus 16t squared. There's my function. That's my distance function. Okay? Part A says, what's the average velocity of the ball over 3 different time intervals? Okay? Well, if they say the first interval is from 2 seconds to 3 seconds, I want to find that velocity. Well, what that says, if t is 2, I would put that in and find what the height is. So I would say this leads to the ordered pair 2, comma, whatever I get when I put that in. Now, just to make things easier, and we could all do that by hand, but if I entered that in my calculator, if I said 128t minus 16t squared, I could go right to my table, couldn't I? And I'm going to delete what's there, and I'm going to say at 2 seconds, what do you get? 192. So look at that ordered pair. If I put 2 for t and work that out, I get 192 for s. If I plug 3 for t, go back to your table. If I plug in 3, what do you get? 240. So if I plug 3 here and here, the distance, the height is 240. The rest of it's just finding the slope. That would be the average velocity, and I'll call it that. The average velocity would equal 240 minus 192 over 3 minus 2. And that's going to be 48. Is that correct?
Yeah.
48, and that was in the units given were feet per second. So between 2 and 3 seconds, that ball is rising. It's a positive 48 feet per second, wasn't it? That's the average velocity. They also ask you to do it for other intervals. Let's do one more before we move on. If I did 2 to 2.5 seconds, between 2 and 2.5, these are my t values that I'll plug in to get the ordered pairs. So if t is 2, we already saw it was 192, didn't we? But let's go back to our table, and if t is 2.5 here and here, if I plug in 2.5, do you agree with that 220? Okay. So the average velocity for that pair of points is the slope between these. So I would have 220 minus 192 over 2.5 minus 2. Help me with that. 28 over a half. Is that 56? Is that right? Okay. Very good. So, from 2 to 2.5 seconds, it was actually rising quicker than between 2 and 3 seconds, wasn't it, on the average? And you see what's happening. If you graph that, that's a downward parabola, isn't it? So maybe from 2 to 3, we had that line, and we found the slope of it. But from 2 to 2.5, it was a little steeper, wasn't it? That was the slope of the first, maybe like 48. 56 was a little steeper because it was a little smaller area of that curve, okay? What we want to do, though, is what if I said to find the instantaneous velocity, maybe at 2 seconds, I'm going to have to bring this other point so close to that one to make this line that they're almost the same point. That's what we're talking about with instantaneous velocity. What will this slope be if those 2 points are so close together that it's basically that one point? And that's the way we're going to define that next term, instantaneous velocity. So look at this. Back to our notes. If I go up a little bit. Instantaneous velocity. Velocity at a particular time t0. Okay? So what that's going to say, if I find this limit, that's going to be the instantaneous velocity. And see what I'm doing there is we're saying, what if we were looking at like on that previous example, what if we wanted the instantaneous velocity at 2 seconds? And that was the point on the graph when t is 2. Okay? I'm not going to actually have another point, but I'm going to say, what if the other point is just h units away from it, and I let h go to 0? So it's almost like nothing. They're almost like right together. That's where this comes from. Because what I would have, if you look at that formula again, f of t0 plus that little number h that's going to 0 minus f of t0 over t0 plus h minus t0, which just leaves the h down there. So it's still the slope formula between those 2 points that are so close together. But all I have to find is that limit, and I've got my instantaneous velocity at that one point. That's what they're asking me to do in 30b. What's the instantaneous velocity at time t equal 2? Well, let me erase some of this. So for part B, let's use that. Okay. So part B says the instantaneous velocity at time t equal 2 seconds. We just saw, and I can bring that back up if you'd like, the definition. The limit as h approaches 0, this will be a 2, and that will be a 2. Okay, for this problem. So let's do that. That will be the limit as h approaches 0. In this case, it was s. S of 2 plus h minus s of 2 seconds over h. Do you see maybe why in previous sections they were trying to make us do this? Because soon that's what was coming up, right? So if I can find this limit, I've got it. We've got to work on it. Can you help me find this? What does S of 2 plus H mean? Plug 2 plus H where? Here and here. So I'm going to say 128 times 2 plus H minus 16 times 2 plus H squared is that. Minus this. We know this. What did we get when we plugged 2 into that? Was it 192 over H? To find that instantaneous velocity, the slope of that line at that one point, I've got to find that limit. I've got to work that out. That doesn't look fun algebraically, does it? But it's not bad once we get into it. Let's do it. So would you agree I have the limit as H approaches 0? This is going to be 256 plus 128H. And I'm not leaving myself enough room, am I? 256 plus 128H, if you don't mind, I'm going to erase that. Okay. Minus, if you agree to distribute this out, it's going to be 4 plus 4H plus H squared in that box. 2 plus H times 2 plus H. I've got to distribute this 16 to each of those three terms. Minus 16 times 4 is 64. Minus 64H. Okay. Minus 16H squared. And what's at the end? It's minus 192. Big numerator over H. The next step is going to fit because I can simplify a lot. Once I distributed all that out and I got this, what do you see? Do you see that we've got 256? Well, look at this. Minus 64 minus 192. Don't those cancel out? 256 minus 64 minus 192 is 0. That's great. What's 128 minus 64H? 64H minus 16H squared. And that's all that's left. Much better. The limit as H approaches 0, if I factor out an H, 64 minus 16H, what happens? H cancels. What if H goes to 0 now? What's my limit? 64 feet per second at that instant is my answer. That looks like a lot of algebra, doesn't it? But it's just that definition. S of 2 plus H, plug in 2 plus H, minus S of 2, which was 192, all over H, and take the limit as H goes to 0. The rest was just distributing that out and simplifying. And I promise, after this test, and I get you to do one of these by this definition, we've got rules that make it so easy that you're gonna almost want to punch me that it's so easy that I made you do this, right? Okay? But I need you to do this for 1 or 2 problems before we get to those rules, because that's the definition of this instantaneous rate of change. Okay? What do you think? Did you see how that made sense from our definition? My function was S, wasn't it? And T naught was 2. I plugged 2 plus H into my function, and I got this here. Then I plugged 2 into my function, and I got that. Divided by H. I just worked it out and distributed, and then I took the limit. You want that quiz? All right. He told me he had to leave. He's not just being grandstanding. So. Some of you know I don't like that too much, but he did tell me. Let's see. Would you like to try another one?
Where I'm missing the 16H.
Yeah, I'm missing where the one.
I'm missing this.
Okay.
Missing the last step.
128H minus 64 is 64.
Oh, well, okay.
Minus 16H. So see, I just simplified all this, and see the constants canceled out. See, 256 minus these two is 256 minus 256, so they disappeared. So then, when I took that and combined them, that was my 64H. When I factored out the H, it canceled, and then my limit was 64. So think about, you remember that graph I just erased?
Yes.
Remember we said this first average velocity was like 48? Then it was steeper when you got closer. It was like 56, wasn't it? Well, if I get so close to that, it was 64. It's even steeper, right? So the instantaneous velocity at that instant, it's going pretty fast. But isn't it starting to slow down as it gets to the top, and then it's going to start to fall? Makes good sense, doesn't it? Now, what they want you to see is if you went to 5 seconds and you did it over here, you're going to have a negative instantaneous velocity. In other words, it's falling at a certain amount of time, feet per second, right? That would be a negative instantaneous velocity. That slope's negative, you know that, right? This was positive slope, that's negative slope. So it depends on what you choose.
So on the bottom,
Yes.
the negative 16H completely disappears because it's irrelevant.
Because if H goes to 0,
Gotcha. That's
very good, very good. My question is, could you do that in one problem on Monday? And could you do it on one problem on the quiz that you're taking home?
are we going to have to make it?
I would like you to know that, okay? Just because that's going to be our definition of derivative next week when we get to our new notes, when we start our notes next Wednesday. Yes, yes. What if we said, what if this is not talking about distance and velocity? What if it's just a plain old function f of x? Do you see back up at 28? What if they just said, find the average rate of change or instantaneous rate of change? Let's see if we can do 28. F of x is x squared minus 4x. I like these numbers better than the 128, don't you? Okay. Part A says find the average rate of change of y with respect to x from 3 to 4, if x is from 3 to 4 on that interval. Just like when it said from 2 seconds to 3 seconds in the last problem. Okay? Let's start with that. Well, on this function, from x is 3 to x is 4, I need to find those two ordered pairs, don't I? If x is 3, could you just look at that and tell me what y is? If x is 4 in this function, what is y?
0.
Do you agree that from x is 3 to x is 4, these are the two ordered pairs that are generated? What would be the average rate of change, which is the slope? What would I plug in?
0 minus negative
Good. Over.
4 minus 3.
What is that average rate of change? 3 over 1 is 3. That would be it. Slope formula between those 2 points. And you see that these were both x values, weren't they? I had to have the y's that go with them from that function. And then I just found the slope of that line, connecting them. That's the average rate of change. They also asked me to do 3 to 3.5 and so on, but you saw what that was doing. That was just, Why don't we go right to the meaty one? Part B, look at what it says. Find the instantaneous rate of change at x equal 2. No, at At x equals 3. Look at the wrong one. Instantaneous rate of change at x equals 3. Now, what definition do I use to find this? It's the what? The limit as h approaches 0 of what fraction? F of 3 plus h. Do you want to look at it again? All right. F of 3 plus h minus f of 3 over h. Definition. Okay. And down below, I redefine this. Instead of instantaneous velocity, I define it as instantaneous rate of change, which is exactly what we would use for this one. Same thing, right? Okay. Instead of t's, they're x's. So, okay. F of 3 plus h minus f of 3 divided by h. If you don't mind, just to have room, I'm going to bring it over here. If that's okay. If we say limit as h approaches 0, f of 3 plus h means put 3 plus h here and here, doesn't it? That would be 3 plus h squared minus 4 times 3 plus h. Well, I'm done with this part. I am done with that. Could you tell me, we've already seen what this is. What is f of 3? If you plug in 3, we got what? Negative 3. So this is minus negative 3 over h. Okay? You see where we got that? F of 3 plus h is here, minus f of 3 over h. I've just got to expand that out and simplify. The limit as h approaches 0. If you expand this, would you agree that 3 plus h times 3 plus h is 9 plus 6h plus h squared? If I expand that? If you distribute it out, you get that, don't you? 9 plus 6h plus h squared minus 12 minus 4h. What does this become? Plus 3 over h. Does that look good? Okay. Tell me what that numerator is going to simplify to if I combine.
5h plus h squared?
2h. 2h plus h squared.
Would that be 2h plus h squared over h? You agree? Everything else canceled. 9 minus 12 is negative 3 plus 3 cancel. Just like before, I'm going to factor out an h. What happens? H is canceled. If h goes to 0, what is my limit? 2. Okay?
So why is it worse?
Good question. I'm glad you asked it. If I graph this, isn't that an upward parabola? So if I went, let's say, maybe from 3 to 4, what if 3 to 4 is over here? All right? And then I just say at 2, what if 2 is down here? Isn't that going to be a smaller slope?
Yeah.
Because that's an upward parabola, isn't it? So this might be higher than that one is at that one point. And the way we're defining this, remember I said we're trying to get 2 points so close together they're the same? That's called the slope of the tangent line at that point, where it touches at that one point. And we're going to talk a lot about, if you have a curve, what is the slope of the tangent line later on.
And that's the same as the instantaneous.
Say that.
Is that the same as instantaneous rate of change?
Yes. Slope of the tangent is the instantaneous rate of change. Because those 2 points are so close together, they're 1 point, aren't they?
And the other is the secant.
The other
Secant.
was the average
Slope of
slope of the average rate of change or average velocity. They're further apart, aren't they? Where you actually just use the slope. So that's not a bad concept. You know what really bothers people about this is the algebra. They know that definition, but trying to plug that in and simplify it just makes you go crazy, doesn't it? But that's not bad, is it? Do you think you could get home and if it confuses you, you rework this one and say, well, what did he do? You know, without looking, and then try the one from the book, one or two. And I promise, there's one on the take-home quiz like this, and there's one on your test. And if you can get through that, like I said, you're going to be able to look at this next week and tell me what this answer was without all of that work. You'll look at that and you'll say, it's going to be 2. And you're going to be so mad at me, but you're going to say, I'm so glad that we don't have to do it like this every time. But I have to be hard-nosed just for once, all right? And we'll be set.
So where do
So,
we punch you next week?
what's that?
Where do we punch you next week?
Just warn me beforehand, okay?
We can take you out there to the trail, you know, nobody will notice.
I'll stand right over there and you can line up if you need to. That's good.
We're just going to make sure Dr. Stein's class isn't up there.
But these are the only ones that you're responsible for from this set. On page 147, I'm only assigning 27 through 33I. A couple of those might be tougher because they're strange functions, but they're all the same. They all are worked the same. Okay? But if you can do 27 like 28, and if you can do 29 like I did 30, it's going to be so easy, I think, for you. And if any of them confuse you, please see me before Monday. You've got from now to Monday, don't you? Okay? So, do you think that's going to be okay at home? Okay, good. Well, let's back up and talk about what the test will have on it. I'm going to be very explicit about what you need to do to get ready for this test. I would first say what I would do is review quizzes 1, 2, and the one I'm handing out as a take-home. These 2 you already have graded. Make sure you can correct those mistakes and feel good about them. Okay? There's not a lot of quiz 1 on the test. Mostly it's going to be what I've got on quizzes 2 and 3, because 1 was just a review of algebra mostly, wasn't it? But here's exactly what's on the test. Okay? I'll give you one question where I say, is something a function? What's the domain? And what's the range? Just like I think I did give that on quiz 1 maybe. Then, how about a composition of functions question, like I started quiz 2 with? Look back over that and correct those if you need to. We also had cost, revenue, profit on this last quiz. You'll see another one of those. And the break-even point. Okay. Supply, demand, and point of equilibrium. Just like the last question on quiz 2. Then it goes to all that we did with limits in 2.4 and 2.5. Limits, one-sided limits, continuity that we did last time. And last but not least, average and instantaneous velocity or rate of change. What we just did 2 seconds ago, this was instantaneous rate of change, wasn't it? That's it. If you can review this was from quiz 1, quiz 2, 2, 2, 2, 3, 2, and 3. It's going to be it. It's not a long test, but it tells me what I need to know. Okay? Do you have any questions about it? Do you promise that before Monday, if any of that quiz 2 you're not able to correct and understand what you missed, you'll come see me? Okay? All right. What I would like you to do, we still have a good 30 minutes. Why don't you start working on quiz 3 and see if you can get a few right, and I'll tell you if they're right or wrong before you go. Okay? And just do as much as you can. If you need to finish it some, that's fine, but it's due Monday before your test. But I think it would be nice if you got a good start on this.
We got them wrong. We don't get the points enough, right?
Oh, no, not today.
Not so much.
I'll just, you know what, if you get it wrong, I'll say that's not right, and you'll try again.
Alright.
But I'm not going to try it wrong. Until you turn it in Monday, then I'm right. I want to see if you get some of these right before you leave. And we'll see what happens. Do you all see that number 4 is exactly what we just did? If it's fresh on your mind, go for it. Go for it. If not, try some of those limits. Try your definition of continuity. Make sure you look at the syllabus in my office hours between now and Monday. Come see me if you need. Try not to make it at 1:45. Can't do much at 1:45 on Monday. But I'll be in there tomorrow and Monday early. Is it okay if I erase this and turn it on? Everybody got it? These are all for that function.
Okay, so BCD.
Yeah, A, B, C, D. And I should have put A, B here. I'm confused with it, sorry. Are these both going here?
This is good. Oh,
So you're saying X is less than or equal to here. What? Let's test it. You're saying this piece is that, but that's for X greater than 2, isn't it? Is that like the positive side?
Oops. Why did we drop that?
Calculated no close, but they're not working with
That's the on.
So remember, the piece, one of these has a total your fee for the extra fee. Let's see. Remember, you've got this definition of the limits. This one was finding the two over here to find the slope of those two. That's your fee. One side is this, one side is that. Oh, that's much better. Much better.
For this one, I've been trying to factor this to see if it equals 6.
Could you word this more like of our three conditions? Which one favors? That's good. I understand what you're saying, but if you gear it toward those three conditions, that'd be great. What are you going to put on this book? Yes. Very good. So put your pieces. Put your pieces for numbers so large. So where would you put it? So what would you do? If X approaches 2, then that means yes. Yes. That's exactly right. Okay. That one thing I'll change my reference for the arrows here, short these on here, and each of those is a closed file, which is an sorry. Is it So it's the same. What does that mean about feet? With that too, it says what the reason. So what do you say? Or what's our what are our three numbers?
Yeah.
And this piece, if you get close to 1, that's like 1 plus 2 plus 5. Then when I ask you this, what do you say? For this to exist, what has to be true about both of these things? I almost want to say that really big. Yes, we put ears on the end of this one. I like that.
Does that look right?
Yes.
Okay, and now putting this back in, is this 10 times 2 plus h squared
Plus 30
plus 30?
for
and
the
then,
C's.
What would that be, 2 plus h?
Yes. And then that's finished. Put parentheses around that.
Okay,
Minus,
and then 2.
plug in 2. And you've already done that, haven't you?
Okay. So it'd be 2 plus, no?
No, if you just plug 2 into there, you got what number?
Okay, 100.
Okay, that's it. Look what I said. You told me that. And you told me that. For this limit to exist, what has to be true about the right and left? They have to be what? Remember, for this to exist,
Oh, it has to be continuous.
it has to be the same limit. Right? So if these are not the same, what do you say?
Not the this.
Okay.
How would you say the
There you go. Oh, that's actually so does that exist? So you're saying two to that piece? What is negative 4?
Just stated all day, all that level.
And
After
for this limit to exist, what has to
12:30.
be true about the
I'll until 4:30 because that's when it closes. So you can come in there anytime now.
I'll probably see if I
Okay.
I know.
So what do you say? Another way to think of it is if you graph that and you approach to 5, look at what happens. One side and the other side. Can you factor that to reduce it? How do you factor it square root? Yes. So what's going to happen with that number? So that's actually what you're dealing with, right? So at x equals 3, that's you're right, it's 6, isn't it? Well, actually, f is 6. The limit plus the limit as x approaches 3. If x gets close to 3 in your reduced form, the limit is. Well, see, this will be left in x. If x gets close to 3, 3 plus 3. So what's our answer? Is it continuous? 6, 6, 6 plus 6. That's what I want. That was right. This was 6. The limit from this one, once you reduce it, goes to the same. So all 3 conditions are met. Anytime you can factor do it. And remember, if you ever get, you told me this was 0, 0, so if it's ever 0, 0, algebra will manipulate it till it's not. Factor cancel, like remember when they did the radical and they did the conjugate? Do anything you can algebraically to remedy that.
I'm serious, I gotta leave, but am I like getting in the right direction?
Yeah. 10 times 2 plus h plus, yeah, minus that. That's right. Once you simplify that and take the limit as h approaches 0, you'll get that. Now this one, did you factor?
No, I used the
That's right. I like the conditions. But what I'm saying is, this is 0 over 0 there, so it's close to 3, right? You've got to factor that in cancel. And then, so fix that one, but everything else is good. If you guys need to go, I'm not going to complain. You've made a good start. If you have any other questions to ask me, stick around or come see me. But I hope feel like you've got a good start on it and know what to expect Monday. That'll be great. But if you have any others to ask before you leave, I'm right here. So. Is this your music library, Renita? Is that your music library?
There's no telling what that's saying. Oh, yes, it is.
You got all those? I'm
Yes.
impressed.
Oh, really?
I saw some twisting around that I thought, I've got those. Not a lot of the country, but some of the others I saw Coldplay.
Yeah.
Yes. Same type set. Very comfortable. if you study the quizzes right.